Congress is focused on key questions. What happened and who is responsible? How much oil has spilled and what is the impact? How do we make decisions in the face of uncertainty? We face similar questions when confronted with the looming disaster of climate change caused by carbon pollution. In both instances, lawmakers need to be informed by the best available science as they make decisions and seek clean energy solutions. Today, we are joined by some of the world's foremost climate scientists, including the President of the National Academy of Sciences and a Nobel Prize-winning atmospheric chemist. These scientists have been instrumental in informing the clean energy and climate change policy debate. Their work has helped identify the fingerprint of human activity on global warming amongst the background of natural variability. They have provided a risk framework to guide policymakers in the face of evolving science. Just yesterday, the National Academy of Sciences issued 3 major reports about the science, the solutions, and the ways to adapt to climate change. These reports reinforce the overwhelming foundation of knowledge we have about the danger of carbon pollution. This is a foundation still unshaken by a manufactured scandal over stolen emails. This knowledge was gained in an America that supports creative, inquisitive scientists. American scientists enjoy the freedom to follow the science where it leads and to work collaboratively and sometimes combatively with their colleagues. Preserving this freedom to explore new ideas and technologies is critical to understanding our world and finding solutions to our clean energy challenges. Given the relevancy of their work to national priorities, our best scientists are increasingly drawn into the political arena. Disagreements over policies have led some to target both the science and the scientists themselves. The latest and most overt incident came earlier this month. Virginia's Attorney General, Ken Cuccinelli, demanded the materials be turned over by the University of Virginia relating to 5 grants that involved a former University of Virginia professor, Dr. Michael Mann. Although Dr. Mann's work has been examined by his peers and found to be sound, the Attorney General is using this controversy over his research as an excuse for a fishing expedition. The request to UVA asked for materials related to 39 people. Some of these are critics of Dr. Mann. Some of them are far outside the field of expertise or the grants in question. Instead, the list reads like a Google search of climate, emails, and IPCC. The Attorney General doesn't even ask for the records associated with all of Dr. Mann's co-investigators on the grants. If the investigation were truly about fraud, as the Attorney General claims, then you would expect him to seek all documents related to all of the scientists involved in the grants. This week, over 800 Virginia scientists sent a letter to Cuccinelli suggesting his demand is transparently political and designed to intimidate. This attempted intimidation is not new, but it is getting worse. 2 weeks ago, 255 members of the National Academy of Sciences, including 11 Nobel Prize winners, published a letter in Science magazine decrying the treatment of climate scientists and warning of the chilling effect on the greater scientific community. The majority of climate research in the country is supported by federal funding. Recipients of these funds have a duty to work in an ethical, transparent way and to communicate their findings in support of societal needs. Our witnesses today are dedicated to that premise, despite attempts to portray them to the contrary. It seems fitting to close with a quote from the recent scientist's letter. Quote, "We can ignore the science and hide our heads in the sand and hope we are lucky, or we can act in the public interest to reduce the threat of global climate change quickly and substantively." I would now like to recognize the ranking member of the Select Committee, the gentleman from Wisconsin, Mr. Sensenbrenner.
I thank the Chair. Unfortunately, I have to begin today by addressing conduct from the committee's last hearing. 2 weeks ago, the minority's witness, Christopher Monckton, argued that there have been 3 distinct periods of warming in the past 150 years, and that the rates of warming in each of these periods were parallel. He demonstrated that both the EPA and the IPCC were wrong to claim that the rate of warming in the most recent period was higher than the 2 previous periods of warming. Finally, he questioned whether CO2 was the most likely cause of warming if previous temperature rises were identical when atmospheric concentrations of CO2 were much lower than they are today. Neither the majority nor its witnesses responded to any of these arguments. Instead, they attacked Lord Monckton for not presenting scientific information, even though he clearly did. They ridiculed his name, and they wrongly accused him of falsifying his credentials and then refused to allow him to respond. I encourage everybody to read the transcript or watch the video on the committee's website. It was bullying and it was embarrassing. As Lord Monckton said in response, a certain amount of politics has crept in on one side of this debate, and therefore inconvenient science has been dismissed as not being science at all. I want to be clear that not all members of the majority stoop to these levels, and I thank the chairman in particular for his professionalism. But the politicization of science from some members of the committee is a legitimate threat to scientific understanding. Sadly, last week's hearing echoed the shameful culture exposed by the ClimateGate emails. ClimateGate revealed a scientific culture that is more interested in defending its findings than in finding truth. It showed some of the most prominent scientists in the world actively working to sabotage legitimate scientists who dared to challenge their work. The majority repeatedly tried to dismiss the ClimateGate emails, but no number of politically motivated studies will change what the emails actually say. And I want to read a few quotes. Quote, "I tried to balance the needs of the science and the IPCC, which were not always the same," unquote. Quote, "There is pressure to present a nice, tidy story as regards apparent unprecedented warming in 1,000 years or more in the proxy data. But in reality, the situation is not quite so simple," unquote. Quote, "If you think that Sayers is in the greenhouse skeptic camp, then if we can find documentary evidence of this, we could go through official AGU channels to get him ousted," unquote. "I got a paper to review written by a Korean guy and someone from Berkeley that claims that the method of reconstruction that we use in dendroclimatology is wrong, biased, lousy, horrible, etc. If published as is, this paper could really do some damage. It won't be easy to dismiss out of hand, as the math appears to be correct theoretically. I am really sorry, but I have to nag about that review. Confidentially, I now need a hard and, if required, extensive case for rejecting," unquote. Quote, "I can't see either of these papers being in the next IPCC report. Kevin and I will keep them out somehow, even if we have to define what the peer review literature is," unquote. There are literally thousands of these. These emails expose an intolerant scientific culture, and they raise legitimate questions about the strength of the so-called scientific consensus. The minority witness today is Dr. William Happer. He is the Cyrus Fogg Brackett Professor of Physics at Princeton University and a member of the American Physical Society and the National Academy of Sciences. He has spent his professional career studying the interactions of visible and infrared radiation with gases, which are the physical phenomena behind the greenhouse effect. Dr. Happer has long argued that increased accumulations of CO2 will not lead to the temperature increases that the IPCC predicts, and that the results of climate change will not be as catastrophic as claimed. Dr. Happer is very familiar with the politicization of science. Al Gore fired him from the Department of Energy because of his beliefs. In a criticism of then Vice President Gore, Ted Koppel, no conservative, said, quote, "The measure of good science is neither the politics of the scientist nor the people with whom the scientist associates. It is the immersion of hypotheses into the acid of truth. That's the hard way to do it, but it's the only way that works, unquote. Finding errors in data and critiquing scientific work is the legitimate path to truth. Ridicule and attempts to besmirch reputations have no place in this debate, and I yield back.
The gentleman's time has expired. The chair recognizes the gentleman from Missouri, Mr. Cleaver, for an opening statement.
Thank you, Mr. Chairman. To you, Mr. Chairman, and the ranking member, Sensenbrenner, I would like to welcome our witnesses today for this hearing. I'd like to express appreciation to all of you for your efforts in the scientific arena. Science is the basis of our knowledge of the wonderful world we inhabit. And without people like you, we would be sitting in a greater degree of darkness. Personally, I believe that we need to act now to reduce greenhouse gas emissions and to take appropriate adaptation strategies for global effects that are on the way and are already being felt around the world. We have, I believe, a moral imperative to preserve this planet for future generations and for our progeny. My concern is that we now exist in a nation that has simply become mean-spirited. And I think we look for ways in which to be mean. I think some of us get up in the morning and spend time revving up our anger, and then we express it in a variety of ways, some of them not very nice. And I think maybe you are victims of what's going on. I don't celebrate disrespect for anyone, but certainly I do think that what has happened to you is happening in a variety of ways, including the United States Congress. And so I think we've got to take whatever steps we can to do the science and put in place measures that will aid in the healing of this planet. Mr. Chairman, I yield back the balance of my time.
The gentleman's time has expired. The chair recognizes the gentlelady from Tennessee, Ms. Blackburn.
Thank you, Mr. Chairman. I thank you for holding the hearing and our witnesses. We welcome you. We're pleased that you're here. This committee is examining the role of climate science in political decision-making. That's the topic for our hearing today. I think that perhaps we should have a hearing on the role of political decision-making in climate science, and our ranking member has spoken eloquently to that effect. All of the members on this panel agree that we need the best science available to make informed decisions. Unfortunately, recent investigations have shown how academic researchers misused federal funds through distorting data to manipulate lawmakers into adopting certain positions on climate change. Mr. Chairman, most of these problems are tied with the funding that agencies and academics receive for their research from climate science. Instead of producing objective analysis with scientific integrity, they seek to produce results that will lead to more funding in the future. That is really unfortunate and I think unfair for the American taxpayer. Instead of exercising oversight over this analysis, bureaucracies like the EPA occupy themselves with sponsoring YouTube video contests and throwing away tens of thousands of taxpayer dollars in prize money. And now the receivers of federal funding can breathe a little easier as the House majority has decided to not produce a budget resolution for this year. Instead of examining funding for climate science research objectively, the majority has decided to bypass the resolution process and go straight into deeming spending levels. This is a first in 36 years. They do not want to have to reveal to the American taxpayer the huge $1.5 trillion deficit for this year and for the upcoming 4 years. They would rather sweep it all under the rug and hope that the American taxpayers do not notice. But I know my constituents are aware of the tremendous financial problems the U.S. is in, and they want every program and every research grant to be scrutinized so that their money is not wasted. On behalf of American taxpayers, I ask my colleagues to put forth a budget resolution, and I yield the balance of my time.
Gentlelady's time has expired. The chair recognizes the gentleman from New York, Mr. Hall.
Thank you, Mr. Chairman, and Mr. Ranking Member. I'm glad you're holding this important hearing today, and I want to apologize at the outset that I will have to leave shortly because I'm chairing a hearing on the Veterans Affairs Committee on the VA's efforts to deal with military sexual trauma, and that will be starting shortly. But thanks to our witnesses and other members of the scientific community who first brought to our attention the phenomenon of global climate change. Regardless of where you stand on the science and what you believe is the truth, it happens to be that my colleague Ms. Blackburn's constituents and mine and others around the world are suffering already from the effects of climate change, in my opinion. Computer models that show increased storm frequency and storm strength are being borne out. The flooding, the massive flooding in Tennessee, massive rain event and flooding in Tennessee, which many of my friends lost everything in. My mother-in-law's condo, which she used to live in, was up to the eaves in water. The week before that, the Mississippi tornado that was a mile wide and killed many people in that state. A week before that, massive rain event and flooding in Stonington, Connecticut, and Warwick, Rhode Island, and other parts of New England that had 6 feet of water in the malls and the Warwick Mall, and many businesses in downtown Stonington flooded out. The week before that, Paterson, New Jersey, and my farmers in Orange County, New York, experiencing their 4th 50-year flood in the last 6 years. The island of Madeira off the coast of Spain, where a rain event caused massive mudslides that washed people and homes and cars out to sea. The freak March Hurricane Cynthia, months before the beginning of hurricane season, that hit the coast of France and killed 40 people, all seem to me to be evidence that the weather patterns are changing, regardless of what emails are going back and forth. So, and lastly, I would just say that the solutions, even if climate change were not true, the solutions that we need to look for are the ones that will provide us with a positive balance of trade, new jobs in this country, and independence, and recovering our sovereignty from those countries that we now depend on for oil or to borrow the money to pay for that oil. And with that, I thank you, Mr. Chairman, and I yield back.
We thank the gentleman very much. That completes opening statements from members. We'll now turn to our witnesses. And our first witness this morning is Dr. Ralph Cicerone. Dr. Cicerone is the president of the National Academy of Sciences and the chair of the National Research Council. Previously, Dr. Cicerone was president of the American Geophysical Union and chancellor of the University of California at Irvine. He has been the recipient of many awards. We welcome you, Doctor. Whenever you feel comfortable, please begin.
Thank you, Chairman Markey, for the invitation to appear before you and Ranking Member, Minority Member Sensenbrenner, and the other members of your select committee today. With your permission, I will read from my prepared testimony, but I will not read all of it due to time limitations. I'd like to, as most of you know, the National Academy of Sciences was created by Congress under President Lincoln in 1863 with a mission to respond to requests from the federal government on all matters of science. Thus, we are not part of the federal government, but we were created by the federal government. We elect our members annually based on their original contributions to research in their fields of science. And today we operate largely through the National Research Council, which serves us and our partner, the National Academy of Engineering. We're very proud of our history of independence and our objective analysis, and we work very hard to maintain it. The individuals who serve on our study committees are not compensated except for their direct expenses, such as travel. I'd like to present a brief summary of what scientists have learned about contemporary climate change, then go on to briefly describe our new National Research Council report, America's Climate Choices, and conclude with some remarks about how to protect and improve the ability of scientists in their research conduct and in their communications with the policymakers. I'll start with some brief summary on data, things we're actually measuring. First, the temperatures of air and water. The most striking feature of these data is the rise in temperatures over all of the world since the late 1970s or perhaps 1980. The warming is strongest in the Arctic and over world land areas, with smaller warmings over oceans. When you average over the entire planet day and night, you find about 1 degree Fahrenheit since 1979 of warming. There are several groups around the world who do this work, notably in the United States, the Goddard Institute for Space Studies at NASA and the National Climatic Data Center of NOAA. To see these patterns clearly of temperature change requires continuous, sustained efforts. For example, when we look at small regions and short periods of time, we can get fooled easily by the ups and downs of local weather or by changes that do not go on to persist. For example, during this past winter, New York and Washington were relatively cold while Montreal was relatively hot. The year 2009 as a whole was the warmest on record for the world south of the equator. So even with a variable as simple and familiar as temperature, we need sustained measurements from many places as opposed to simply relying completely on our own senses to tell us what's happening where we live. Ocean surface temperatures are also on the rise. We see this from shipboard measurements and from recent satellite observations. It's a global warming. Temperatures vary with water depth, and the most important ones to keep track of is the total heat content of the upper oceans, the water that are in closest contact with the air. Arctic sea ice. Most of us are aware that the horizontal extent of the ice covering the Arctic Ocean has shrunk, with especially rapid decreases in the amount of open water in the summertime Arctic in the past decade. This decreasing horizontal extent has been visible, literally, from satellite images and from reports of marine navigators, but a measure that has not been known as widely and is much more difficult to obtain is the thickness of the Arctic sea ice. We now know that the thickness has decreased by more than 50% in the last 50 years. These data come to us from recently declassified U.S. Navy work and recent satellite data. Ice on Greenland and the Antarctic continent. There are massive amounts of ice perched on Greenland and Antarctica, and they are very important in Earth's climate. Just in the past few years, about 9 or 10 years, it has become possible to measure changes in the masses of ice in these two places. The data show that ice is being lost and at accelerating rates. Of course, snow is added during the respective winter times and lost in the following summers, but rather than being in balance, the net annual change is negative and increasingly so. These key measurements are from NASA satellites, which use ultra-sensitive gravity measurements and sophisticated radars. Sea level. Sea levels are rising worldwide. The measurements are now made by specialized radar ranging instruments on Earth-orbiting satellites. Prior to 1992, the best estimate of global average sea level rise was about 1.6 millimeters a year, and there were significant differences from continent to continent. Now the observed rate is twice as much, and 3.2 millimeters a year, and the worldwide average is known more clearly. And we can explain this sea level rise much better than 10 years ago by simply adding the rates due to the warming of water, which expands the water in the ocean, the loss of ice from Greenland, the loss of ice from Antarctica, and the loss of ice from continental glaciers. So that picture is becoming clearer. There are many other climate indicators which I won't go into now, except that more high-intensity precipitation events are being recorded, as Representative Hall mentioned. How do we explain and predict the climate change? Well, the greenhouse effect, the physics of it, has been known for about 100 years now, and we've obtained increasingly quantitative information on what's in the air, how it's changing, and where the chemicals are coming from, largely from human activity. Not only does the greenhouse effect and the energy balance calculations from it tell us what's happening and explain reasonably well the warming that we're seeing, but there really is no other theory that's come forward, despite the best efforts of all of us for the last 30 years to come up with an alternative explanation. So we gain more confidence in the explanation that the greenhouse gases are the driving force. Now, the reports that we released yesterday, May 19th, called America's Climate Choices, are broken into 3 pieces. One is called Advancing the Science of Climate Change. The second is called Limiting the Magnitude of Future Climate Change. And the third is called Adapting to the Impacts of Climate Change. I don't have time to summarize these reports, but I would be glad to try to answer any questions that might arise. On the conduct of science, Chairman Markey, you asked us what policies might be necessary to protect and improve scientists' ability to conduct research and to share scientific information with policymakers. First, on the conduct of climate research, the good news is that we have one of the essential ingredients: smart and motivated scientists, many of whom are very young and are drawn to this field. They're ready to go, and many of them are already involved. Of course, they need instruments and computers and access to data from all over the world. I do know that some scientists have been harassed and threatened, but so far I do not see the need for protections aside from our normal civil laws. Instead, perhaps as Representative Cleaver said, an atmosphere of civility and of encouraging scientists to seek the truth and to share their findings is always needed. The biggest difficulty of sharing information, I believe, is one of communication. The scientific jargon, the scientific specialization which is necessary to make progress has made it more difficult for us as scientists to talk outside of our own circles, and we really need to do a better job. But a final ingredient is what we call these assessments that have begun to occur. For example, the assessments conducted by the United States Federal Global Change Research Program and those of the IPCC. These are high-level evaluations of all the peer-reviewed literature in the field, written in terms that are more generally understandable, so that the state of the art, the state of the science is defined periodically and communicated as well as possible to the general public. I think those efforts, and of course those of the Academy, try to do the same thing, but those kinds of high-level assessments are essential for this sharing of information more effectively. Thank you, Chairman Markey.
Thank you, Dr. Cicerone, very much. Our second witness is Dr. Mario Molina. Dr. Molina is a professor in the Department of Chemistry and Biochemistry at the University of California at San Diego. He won the 1995 Nobel Prize in Chemistry for his research on ozone layer depletion conducted at MIT. Dr. Molina is the founder of the Molina Center for Strategic Studies in Energy and Environment in Mexico City. He serves on the President's Committee of Advisors in Science and Technology. We welcome you, Dr. Molina. Whenever you're ready, please begin.
Thank you, Chairman Markey and members of the Select Committee, for giving me the opportunity to testify here today. I will attempt to summarize and briefly discuss here various questions concerning the current state of knowledge related to the climate change threat. As we heard in various media reports as well as in these halls, some groups have stated in recent months that the basic conclusion of climate change science is not valid. This conclusion is that the climate is changing as a consequence of human activities with potentially very serious consequences for society. The basis of these allegations is mainly the exposure of stolen emails from the University of East Anglia and the discovery of some errors and supposed errors in the last report of the Intergovernmental Panel on Climate Change, the IPCC. However, several groups of scientists have recently pointed out that the scientific consensus remains unchanged and has not been affected by these allegations. These groups include the one Chairman Markey referred to earlier on, namely the statement from these 255 scientists published in Science magazine. The conclusion is that it is now well established that the accumulation of greenhouse gases resulting from human activities is causing the average surface temperature of the planet to rise at a rate outside of natural variability with potentially damaging consequences for society. I fully agree with this conclusion. There are in fact some errors in the IPCC's report, but in my view they certainly do not affect the main conclusion. I will not review the nature of these errors here. They have been discussed in detail elsewhere. On the other hand, the science of climate change has continued to evolve. New findings since this IPCC report came out in 2007, these findings indicate that the impacts of climate change are expected to be significantly more severe than previously thought. There appears to be a gross misunderstanding of the nature of climate change science among those that have attempted to discredit it. They convey the idea that the science in question behaves like a house of cards. If you remove just one card, the whole structure falls apart. However, this is certainly not the way the science of complex systems works. A much better analogy is a jigsaw puzzle. Many pieces are missing, some might even be in the wrong place, but there is little doubt that the overall image is clear, namely that climate change is a serious threat that needs to be urgently addressed. The scientific community is of course aware that the current understanding of the science of climate change is far from perfect and that much remains to be learned, but enough is known to estimate the probabilities that certain events will take place if society continues with business as usual emissions of greenhouse gases. As expressed in the IPCC report, the scientific consensus is that there is at least a 9 out of 10 chance that the observed increase in global average temperature since the Industrial Revolution is a consequence of the increase in atmospheric concentration of greenhouse gases caused by human activities. The existing body of climate change, while not entirely comprehensive and with still many questions to be answered, it is robust and it is extensive and is based on many hundreds of studies conducted by thousands of highly trained scientists with transparent methodologies, publication in public journals with rigorous peer review, etc. And this is precisely the information that society and decision makers in government need in order to assess the risk associated with the continued emission of greenhouse gases. I would like to emphasize that policy decisions about climate change have to be made by society at large, more specifically by policymakers. Scientists, engineers, economists, and other climate change experts should merely provide the necessary information. However, in my opinion, even if there's a mere 50% probability that the change in climate that has taken place in recent decades is caused by human activities, so society should adopt the necessary measures to reduce greenhouse emissions. But here I'm speaking as an individual, not as a scientist. It turns out that recent scientific studies have pointed out that the risk of runaway or abrupt climate change increases rapidly if the average temperature increases above about 8 to 10 degrees Fahrenheit. Certain so-called tipping points could then be reached, resulting in practically irreversible and potentially catastrophic changes to the Earth's climate system, with devastating impacts on ecosystems and biodiversity. We're talking about changes that would induce severe flood damage to urban centers and to island nations as sea level rises. We're talking about significantly more destructive extreme weather events such as droughts and floods, etc. The risk associated with these tipping points is perhaps only 20–30%, but we have only one planet. And in my opinion, it's not reasonable to play Russian roulette with this one planet we have. I would also like to mention that some groups have stated that society cannot afford the cost of taking the necessary steps to reduce the harmful emissions. There are indeed significant uncertainties about the availability and cost of energy supply and energy end-use technologies that might be brought to bear to achieve a much lower greenhouse gas emissions than those expected on the business-as-usual trajectory. And yet, there is a consensus among experts, namely that the reasonable target to prevent dangerous interference with the climate system is to limit the average surface temperature increase above pre-industrial levels to about 4 degrees Fahrenheit. The cost is only of the order of 1 to 2% of global GDP. And the cost associated with the negative impacts of climate change is very likely larger. Furthermore, besides economic considerations, as we heard before, there is an imperative ethical reason to address the problem effectively. Our generation has the responsibility to preserve an environment that will not make it unnecessarily difficult for future generations in our planet to have an environment and natural resources suitable for the continued improvements of their economic well-being. The global problem caused by greenhouse gas emissions has many similarities to the stratospheric ozone problem. In both cases, it is crucial to change business as usual by collaboration between nations as one global community. But the quick, effective, and highly successful implementation of the Montreal Protocol to protect the ozone layer stands in stark contrast to the Kyoto Protocol, the international treaty developed in 1997 to address the climate change challenge that is currently being reassessed. But society has yet to find a better way to agree on effective actions on climate change. On the other hand, the extent of change necessary to phase out the ozone-depleting chemicals was relatively small and relatively easy to monitor. In contrast, climate change is caused mainly by activities related to the production and consumption of fossil fuel energy, which has so far been essential for the functioning of our industrialized society. Effective action, therefore, requires a major transformation not only in a few industries, but in the great number of activities of society. But the Montreal Protocol stands out as an important precedent that demonstrates that effective international agreement can indeed be negotiated. Thus, I believe that negotiating an effective climate change treaty is feasible, although very challenging. Nevertheless, such a treaty would undoubtedly benefit the entire world, as was clearly the case with the Montreal Protocol. Thank you, Mr. Chairman.
Thank you, Dr. Molina, very much. Our third witness today is Dr. Ben Santer. Dr. Santer is a research scientist in the Program for Climate Model Diagnosis and Intercomparison at the Lawrence Livermore National Laboratory. Previously, Dr. Santer was on the staff of the Max Planck Institute for Meteorology in Hamburg, Germany. He served as a convening lead author for the 1995 report of the IPCC. He holds a PhD in climatology from the Climatic Research Unit at the University of East Anglia and has been a recipient of the MacArthur Fellowship. We welcome you, sir. Whenever you're ready, please begin.
Chairman Markey, I'd like to thank you, Ranking Minority Member Sensenbrenner, and the other members of the House Select Committee for the opportunity to appear before you today. This is my first testimony. I've been employed since 1992 at Lawrence Livermore National Lab's Program for Climate Model Diagnosis and Intercomparison. Our group was established in 1989 by the U.S. Department of Energy. Our mission is to quantify how well computer models simulate important aspects of present-day and historical climate, and to reduce uncertainties in climate model projections of future changes. As you mentioned, I have a PhD in climatology from the Climatic Research Unit of the University of East Anglia. I went to the Climatic Research Unit in 1983 because it was, and still remains, one of the world's premier institutions for studying past, present, and future climate. After completing my PhD in 1987, I devoted much of my scientific career to climate fingerprinting, which seeks to understand the causes of recent climate change. The basic strategy in fingerprinting is to search through observational records for the climate change pattern predicted by a computer model. This pattern is called the fingerprint. The underlying assumption is that each influence on climate, such as purely natural changes in the sun or human-caused changes in greenhouse gas concentrations, has a unique, distinguishing fingerprint. In the mid-1990s, fingerprint research focused on changes in land and ocean surface temperature. This research provided support for the discernible human influence conclusion of the 1996 IPCC Second Assessment Report. One criticism of the first fingerprint studies went something like this: if there really is a human-caused climate change signal lurking in observations, scientists should see this signal in many different aspects of the climate system, not in surface temperature alone. Over the past 14 years, the scientific community has responded to this criticism. We have now performed fingerprint studies with many different properties of the climate system, such as the heat content of the ocean, the temperature of the atmosphere, the salinity of the Atlantic, large-scale rainfall and pressure patterns, atmospheric moisture, continental runoff, and Arctic sea ice extent. The message from all of these studies is that natural causes alone cannot explain the observed climate changes over the second half of the 20th century. The best explanation of the observed climate changes invariably involves a large human contribution. Extraordinary claims require extraordinary proof. The IPCC's extraordinary claim that there is a discernible human influence on global climate has received extraordinary scrutiny. This claim has been independently corroborated by the U.S. National Academy of Sciences, the science academies of other nations, and the reports of the U.S. Climate Change Science Plan. Many professional scientific organizations have also affirmed the reality of a human influence on global climate. Finally, I'd like to make a few comments regarding some of the non-scientific difficulties I have faced. In April 1994, I was asked to serve as convening lead author of Chapter 8 of the IPCC's second assessment report. Chapter 8 reached the now historic conclusion that there is a discernible human influence on global climate. This sentence changed my life. Shortly after publication of the 96 IPCC report, I was publicly accused of political tampering, scientific cleansing, of abuses of the peer review system, and even of irregularities in my own scientific research. Responses to these unfounded allegations have been given in a variety of different fora, by myself, by the IPCC, and by other scientists. Yet the allegations remain much more newsworthy than the rebuttals. I firmly believe that I would now be leading a different life if my research suggested that there was no human effect on climate. I would not be the subject of congressional inquiries, Freedom of Information Act requests, or email threats. I would not need to be concerned about the safety of my family. It is because of the work I do and because of the findings my colleagues and I have obtained that I have experienced interference with my ability to perform scientific research. As my testimony indicates, the scientific evidence is compelling. We know, beyond a shadow of a doubt, that human activities have changed the chemical composition of Earth's atmosphere. And we know that these human-caused changes in the levels of greenhouse gases make it easier for the atmosphere to trap heat and have had important effects on our climate. Some take comfort in clinging to the false belief that humans do not have the capacity to influence global climate, that business as usual is good enough for today. Sadly, business as usual will not be good enough for tomorrow. The decisions we reach today will impact the climate future that our children and grandchildren inherit. I think most Americans want those decisions to be based on the best available scientific information, not on wishful thinking or on well-funded disinformation campaigns. This is one of the defining moments in our country's history and in the history of our civilization. For a little over a decade, we have achieved true awareness of our ever-increasing influence on global climate. We can no longer plead that we were ignorant, that we did not know what was happening. Future generations will not care about the political or religious affiliations of the men and women in this room. What they will care about is how effectively we address the problem of human-caused climate change. Thank you.
Thank you, Dr. Santa, very much. Fourth witness today is Dr. Stephen Schneider. Dr. Schneider is a professor of interdisciplinary environmental studies and biological studies at Stanford University. He has contributed to all 4 assessment reports of the IPCC and served as a coordinating lead author for the 4th assessment. He is as well a recipient of a MacArthur Fellowship and is a member of the National Academy of Sciences. We welcome you, Doctor. Whenever you're ready, please begin.
Thank you very much, Chairman Markey, and the members of the Select Committee. And in fact, the Select Committee has been designed to integrate across multiple committees of the Congress. I think is a very excellent idea because climate change, like many other complex problems, including health care and defense and education, involves that integration, and we need to get out of our silos, so I appreciate this opportunity. One of the things I want to do very fast in my oral testimony is to try to put a little bit of context
on the cacophonous debate that we often see in the world out there, the political world, the media world, and point out that frequently that debate has very little correlation with the debate that actually takes place within the knowledge community, most of which you've already heard described from colleagues. This is not to say there aren't many uncertainties, and my written testimony dwells on the whole history of that. In fact, the IPCC, which you mentioned that I have been involved in all four, in fact, I jokingly call this my pro bono day job, has pioneered in pointing out that when we discuss any conclusion, that the consensus that we're talking about is not simply the consensus about a conclusion, some of which may not be fully established, but the consensus is over the relative confidence we have in those conclusions. That is, we assess risk, what can happen multiplied times the probability, and then we leave the risk management judgments, the what to do about it, the value judgments, where they more properly belong, as Dr. Molina told us, in the decisions that are made by you and others, including private citizens. So let me begin with just a few slides to try to frame this context. One of the questions that I'm often asked is the science of global warming settled? And I like to ask my audiences what they think, and depending who you talk to, it's somewhere between 20 and 70% of people. But after asking how many believe that it is and isn't, I then ask how many think it's a stupid question. Because in fact it is a stupid question. Because most people think of science, what they did in high school. You put in a piece of litmus paper and you can falsify whether it's an acid or a base in my cup of water. But you cannot do that in system science, and you certainly cannot do that for the future, because there is no data in the future until it rolls around. So the question that we have is, what kind of risks are we willing to take with a projection of future that can only be validated by performing the experiment on that laboratory we call Earth? So why is it a dumb question? Because when you have a system science, there'll be well-established components. And there are many that are settled, and we've already heard from colleagues that includes observed temperatures and so forth. There will also be competing explanations. Those things we've narrowed down to a few, and they'll be speculative. And as we heard from the House of Cards analogy, just because there are speculative components does not refute the well-established, nor is it legitimate to take well-established components and ignore the fact that there are still elements that we don't know. So let me give you a few examples in my remaining 2 minutes. We've already referred to the what IPCC called unequivocal warming. Well, there's the record. And you can see that there are indeed, as the ranking member said, a number of pulses, but the most recent one is by far the largest and the one that stands out the highest. But the aspect I want to talk about is on the next slide, because I have heard this asserted many times in the public debate and even in congressional testimony by members, that since it hasn't warmed up much over the last 10 years, that this falsifies global warming. However, if you took a look at what we call cherry picking, that's pick endpoints that are convenient to make a point, between 1992 and 2002, as the slide jokingly says, we were going to hell in a handbasket. What we're looking at is the normal natural variability of the climate system on interdecadal timescales. All modelers, all measurers who understand climate science know this and assert it, and to cherry pick out of context short-term records for political convenience is indeed not sound science, and unfortunately is all too common. It was at a fever pitch when in January there was a snowstorm and cold weather here, which led certain people to assert that this cold snowstorm was therefore proof that there was no global warming. The irony is it occurred in one of the warmest Januaries ever recorded, which no climate scientist would have said proves global warming. It's too short a record. But one snowstorm proves nothing except what the next cartoon does, which is slush for brains. Or why is it going to be covered? This is a serious problem, because when the public and other people actually think there's credibility in the reference of short-term records when we know that there isn't any, that causes a confusion. And when the public is confused, it makes it difficult, I understand, for you to do your jobs of trying to think outside the box from the policy point of view. Let me hurry to conclude. Let me show you an example of competing explanations. There's no competing explanation that Greenland is melting very rapidly. It is. But why is that? Is that a natural internal variability in the North Atlantic climate system, as some have asserted? Undoubtedly, that's a component. Or is this due to global warming? The only way to answer that definitively is hang around another century performing the experiment on laboratory Earth. But there are other things that we can and will do and have done, which is to look at the melt of snow layers over the last 1,000 years. And when you do that high on the Arctic, on the Greenland Glacier, you find that there are many areas that have never melted before. That is not absolute proof, but that tips my belief to it's much more likely than not that global warming is at least a significant component of this, and you cannot rule out a very important part. So let me conclude then by saying, in the future, how do we project? There are two fans of uncertainty. The one in this picture from the IPCC is human behavior, low, medium, high emissions. That's what your committee in the Congress and other people in the world are grappling with, how much in our risk management frame do we want to control. But there's a second fan of uncertainty on the right side, and then last slide, next to the last slide, and that is, what is the internal dynamics of the climate system, the so-called climate sensitivity? If we double carbon dioxide, how much does it warm up? Well, IPCC, which is very conscious of uncertainty, said it was very likely, meaning 2/3 to 90% chance, somewhere between 2 degrees Celsius and 4.5. That still leaves a 5 to 17% chance it could be below or above. And it's those tails of the possibility which are the most threatening and that have insurance companies and others worried. That gives us very clear belief that there is serious potential warming coming, but we still have an amazingly large range that will not be resolved anytime soon. And the last slide is basically one I borrowed from MIT to remind us that what we're really looking at is a wheel of fortune, where if we're, quote, lucky, the lower slots are 2 to 3 times the warming that we're now experiencing. And that's from not business as usual, but a substantial reduction in emissions. And that if we're unlucky and we have high sensitivity and we continue with business as usual, we could see warming of many, many degrees comparable to the differences between an ice age and interglacial cycle occurring not in thousands of years, but in a century. And it's those kinds of outlier cases which, when we're talking about the planetary life support system, that motivate scientists to reasons for concern. Thank you, sir.
Thank you, Doctor, very much. And our final witness today is Dr. William Happer. Dr. Happer is a professor in the Department of Physics at Princeton University. His research focuses on the fundamental interactions between atoms, molecules, and light. Previously, he served on the faculty of Columbia University. Dr. Happer served as Director of Energy Research in the Department of Energy under the first President George Bush. He received his PhD in physics from Princeton. He is a member of the National Academy of Sciences. We welcome you, Dr. Happer. Whenever you're ready, please begin.
Well, thank you very much, Mr. Chairman. I'm going to do my best. I really had less than 24 hours to try to put this together, so I ask your indulgence. May I have the next slide? So when you wrote me, you asked 3 questions. I'm going to try and answer them one by one. So the first question, to what extent does CO2 lead to global warming? And we just heard from Stephen that IPCC says between 2 and 4 is a reasonable guess. I personally think there's very strong arguments that it's less than 2 degrees centigrade. If I were to take an educated guess, I would say less than 1 degree centigrade for doubling CO2. Let me explain why. So can I have the next transparency? This is a plot of CO2 left to right. And on the vertical scale is the rise is the temperature of the Earth that's caused by these changes in CO2. And what you see here is that, I'm sorry, I don't have a pointer, but we're now at about 380 in the outside air, if it's well mixed. And so we're about 1/3 of the way through here. We're in a region of this curve where adding CO2 makes very little difference. So people say this is a saturated curve. You know, we're reaching a point of diminishing returns. Why does this happen? Let me show you the next curve. So this is what the Earth looks like. Actually, this is a model, but there are satellite pictures that look almost exactly like that, lots of them. And what you see here is wavelengths, sort of the color of the infrared radiation going out, and the amount of radiation at each of these different colors, different wavelengths. And you can see, indeed, there's less radiation going out at the CO2 band. That's in the middle of the figure. That's that big gap. And there's a region, the infrared window, which is pretty clear, where radiation goes out almost unimpeded if there are no clouds. And finally, there are regions on the left and right which are heavily attenuated by water vapor and methane and nitrous oxide. Okay, now the question is, what happens, look at that CO2 band that's between the two vertical lines. What happens if we change the concentration? Okay, this is where we are today, 380 parts per million, maybe a little more now. Now suppose you double that. Let me have the next one. I'm sorry, I couldn't get these on the same scale, but what's the difference? Look at the CO2 gap. Please go back. Please go back, forward, back. There's very little difference. In fact, what happens when you add CO2 is that you slightly widen the CO2 absorption band. There's no question about this physics. And it's really not enough to cause very much warming. So the alarming figures of warming assume that somehow this little effect of CO2 is greatly amplified by water vapor and clouds. So that's really the heart of the scientific debate. Okay, next, transparency. Question 2. How important are climate systems, clouds, water vapor, simulated in computer models that are used to predict climate change? And as I mentioned, most models predict that water vapor and clouds will greatly amplify CO2, but there's little support for these from observations. It's really faith in the models. And in my haste to write this down, I dropped a word after water vapor and clouds. I say water vapor and clouds may diminish, please correct the record here, may diminish the warming due to CO2. There is some evidence that's suggestive of that. And furthermore, and most importantly, the models don't predict the big changes of temperature in the past where no fossil fuels were being burnt. Next, transparency, please. Well, first of all, what about the present? These are the various IPCC reports and the central warming trend at each report. There have been, I guess, 4 of them. And you can see every single report has overstated the warming that's been observed, all been overstated. So I think there's an upward bias on the predictions. Next, transparency. This is the celebrated temperature record from the year 1000 to the present. The first IPCC report had the upper figure. This is from Dr. Lamb, the first director of the East Anglia Institute, showing a very pronounced medieval warm period. That's when the Vikings settled Greenland and when Greenland had less ice than now, probably. And the lower is the IPCC report in 2001. They completely eliminated the 1991 in a completely different curve, which shows no medieval warming, no little ice age. Okay, so this is a worry. Next, transparency. We heard this morning CO2 referred to as a pollutant. I actually brought along a CO2 meter. If you permit me, I will look at what it's reading in this room. I don't know, would anyone care to guess what the CO2 level in the room is? Yeah, okay. Well, I sometimes offer a $10 reward. $4.50, okay. Good, Steve. You're a good sport. Anybody else? $5.50, yeah. Ralph wins the golden ring. It's $5.90. $5.90. That's because of all my hot air and my friends here, perhaps. You know, when we exhale air, it's 40,000 parts per million in our exhale breath. So, you know, CO2 really is not a pollutant. You know, you can call it many things, but I think that's really not fair. This is CO2 in the past. Look at the vertical scale. That's the levels in the past. It's measured in thousands of parts per million. You know, it's almost never been as low in the past as it is now. So we're really in a very unusual time with respect to CO2. Next, transparency. Okay, so this was the final question to me. What policies are necessary to protect and improve scientists' ability to conduct research and share scientific information? I would like to argue that this debate is so important that it really has not had the right adversarial review that it needs. And I don't mean internet diatribes. I mean serious studies by scientists. I think we need the equivalent of the Team B approach that is so often used and very successfully in DOD and CIA on important questions. You put together a real tiger team that's charged with coming up with what's wrong with the leading position. So I would strongly urge that such a team be formed, that it be supported by the government, and that it be given every opportunity to make its case. I mean, actually the church used to do that for saints. There was always a devil's advocate, right? A promoter fidei, and if you wanted to be a saint, you had to get through this hurdle. We have not done that with climate change. So that concludes my testimony. Thank you.
Thank you, Doctor, very much. And now we'll turn to questions from the subcommittee members, and the chair will recognize himself. The gentleman from Wisconsin has mentioned a number of issues surrounding climate emails. One that he didn't mention, and which might be the most scandalous, was Vice President Cheney's refusal to accept an email transmitted by the EPA Administrator, Stephen Johnson, during the Bush administration, finding that carbon dioxide is a threat to public health and welfare. In other words, it was actually the Bush administration EPA that made that determination, made the endangerment finding, but the White House refused to accept that finding, which necessitated for Lisa Jackson and the Obama administration to begin again and to make that finding in 2009. I would like to ask all of our witnesses if they believe that the scientific evidence is strong enough to support the adoption of policies that would reduce carbon pollution. Dr. Cicerone.
Yes.
Dr. Molina.
Yes, very much so. Just clarify, this is a statement as an individual, but the science is very clear that the risk is large. As an individual, I think it's not wise to take that risk.
Dr. Santer.
Yes.
Dr. Schneider.
Yes, my value judgment is the same as my other colleagues, and I have fire insurance on my house for a 2% risk, and we're talking about a planetary life support system with coin flip odds of very serious change, and I don't consider it responsible to ignore such odds.
Dr. Happer.
No, I don't. I've explained why. I've explained that we're sitting in a room that's heavily polluted with CO2, and I think more CO2 will be good for the Earth.
Now, you've just heard what Dr. Schneider said about the fact that he takes out insurance on his home, fire insurance, even though there's only a 2% chance that he'll ever have a fire. Is your conclusion based on your analysis that climate science, your climate science conclusions are right, and the consensus is wrong, and as a result, we shouldn't take measures that reduce the likelihood that this can happen, that is more investment in renewables and carbon capture and sequestration and other technologies that can reduce this risk?
I'm certainly in favor of further research in climate change. It's very important. But I do not believe that CO2 is a problem, and I think more CO2 would be good. And that's based on my scientific judgment.
More CO2 would be good?
Yes.
Yes. Dr. Schneider, could you respond to that, please?
Yeah, I'm not sure that most of my marine biology colleagues would agree with that statement, because there's already been a demonstrated increase in the acidification of the oceans. The lab experiments are suggesting that this is not only a threat to coral reefs, but to the bottom of the food chain for the carbon-based shells, and that if we continue on past doubling of CO2, it could very well threaten the bottom of the food chain in the ocean. So whether you like CO2 as a fertilizer of green plants or not, by the way, it also fertilizes weeds, you certainly would not like it in the oceans, and I would consider that to be a highly dangerous experiment to perform in the earth.
Dr. Happer, how do you respond to Dr. Schneider?
Well,
in
I'm
terms
glad
of
he
the
brought that
impact
up
on the
because
ocean?
the Earth has already done that experiment. I just showed you pictures of CO2 in the past where the levels were, 5,000 parts per million, 7,000 parts per million. One of the ways we know that is from looking at carbonate shells in the mud and looking at the pH. You can infer that from the boron-10, boron-11 isotope ratio. So the ocean has already coped with that. Life flourished, so I don't see the problem. And the changes are very small. At levels of several thousand, pH maybe gets down to 7.6. It's 8.1 now. That's half a unit of the pH scale. It's trivial.
Dr. Santer, how would you respond to Dr. Happer in terms of the oceans or any other part of his concerns?
Well, I think my major disagreement with Dr. Happer relates to the feedbacks. Dr. Happer and I agree that in the absence of positive feedbacks, the warming that we would expect due to a doubling of pre-industrial levels of CO2 is relatively modest, less than 2 degrees Celsius. It's the feedbacks that concern me. They're primarily associated with water vapor, with clouds, and with snow, and with sea ice. I respectfully disagree with Dr. Happer's testimony relative to those feedbacks. His testimony indicates that the science indicates that the feedbacks associated with water vapor and clouds are likely to be close to zero. That's not the case. Many assessments which have looked at the water vapor feedback, for example, have showed clear evidence, for example, from the special sensing microwave imager, that water vapor has been increasing in Earth's atmosphere since 1988. Those increases are consistent with very basic physical theory, with what we call the Clausius-Clapeyron relationship. Water vapor is a greenhouse gas. We expect it to amplify the CO2-induced heating of the planet, and that's what we see in observations, in climate models. We see that operating on a range of different timescales, on monthly timescales, between La Nina and El Niños, and even on decadal timescales. So unfortunately, I think the observational evidence for a zero or close to zero water vapor feedback is just not there.
Thank you. Dr. Molina, do you have a comment?
Yes, I again respectively disagree, but disagree very strongly with Dr. Happer's statements. Take, for example, the geological record. I think we certainly don't have time here to look at all the details, but here again, if you take a very serious scientific analysis of the record, I'm talking about millions and millions of years, as carried out, for example, by Dr. Richard Alley, who recently has talked about these issues, it's very clear that this record shows that indeed carbon dioxide is a very important component of the climate. And of course, we have seen very different environments in the past. We've done the experiment. Life also thrived in our planet before there was any oxygen. Okay, but that's many millions of years, so it doesn't mean that we could do that again. So relatively small changes in the system, the planetary system, at the moment, on a short time scale, we're talking about decades, could certainly have devastating consequences in principle for society. And certainly the climate has seen very large extremes millions of years ago, but we certainly would not want to go again through those extremes. It would be exceedingly unwise.
Dr. Cicerone, I'd like to get your comments before my time expires.
Thank you. Yes, I think the forcing due to carbon dioxide increases is significant, but when we add in the destabilizing effects of adding the increased water vapor is when the future predictions get worse. Now, I disagree with what Dr. Happer said. We all know that as we heat up water, it evaporates faster. In the wintertime, when we go around in very cold air, one of the reasons we have static electricity and so forth is that the air is so dry. It's a fundamental physical principle Dr. Sander mentioned the equation, but we don't need the equation to see it. We can measure it. Water vapor does increase as the temperatures go up. Evaporation gets faster. The evidence in the atmosphere we're seeing from satellite measurements shows that it's happening. The burden of proof for such a strong statement that there is no increase in water vapor with warming temperature, the burden of proof has to be on those who claim that, because it's against not only theory but hundreds of years of observations. Finally, about the paleoclimate changes, when you go back hundreds of millions of years, Dr. Molina is right that life on this earth has thrived in all kinds of extremes, including a complete lack of oxygen. That doesn't mean that we would thrive. Also, the changes, the rate of those changes, they took 50 million years to happen, 100 million years to happen. The changes that we're driving now are happening in decades. It's not clear that any living form can adjust so fast.
Thank you. My time has expired. The chair recognizes the gentleman from Missouri, Mr. Cleaver.
Thank you, Mr. Chairman. Dr. Happer, you and I do agree on some things, and even if we didn't, I'm one of the silly people who believe that we ought to be able to have a civil and intellectual discussion without calling names and threatening and that kind of thing, which is one of the tragedies of this moment in U.S. history that I will not contribute to. You and I agree that atmospheric concentrations of CO2 have increased over the last century, and that combustion of fossil fuels has contributed to the amount in the atmosphere, and that increasing amounts of CO2 will increase the global temperatures. I think our disagreement begins after that. You're saying that this is a question, that does not pose any danger to either the environment or the creatures on this planet. Am I correct?
That's correct.
In a garage that has been with the doors closed, and even with the reasonable amount of oxygen coming in, and the car is left running, will that do any damage to an occupant in that garage?
Yes, of course, but not because of CO2, because of CO for carbon monoxide. I'm not in favor of carbon monoxide.
What yeah, I'm not either. We agree again.
Great.
The point is, you may have just drawn it even clearer. So CO2 is as harmless as oxygen.
CO2, I'm sorry, I just didn't hear.
Is just like oxygen, just harmless. It's not.
It's more than harmless, it's good. It's good for plants. And just to follow your analogy, it's very common for greenhouse operators to buy lots of propane, not to warm the greenhouse, but to burn the propane to make CO2, which they funnel into the greenhouse like your car, but they burn it so there's no carbon monoxide. It's, with excess oxygen. Mm-hmm. And the plants do just fine. The CO2 levels go from 380 to 1,000 at least, often 2,000, in 15 minutes. The plants are very happy. It's worth doing that because you get better product. And all the little bugs and things do just fine. None of them die.
Some plants don't seem to be happy. There are some plants that are not expressing joy. Particularly when you go to some of the tropical areas, and there are some animals that are not happy. We were in Greenland, and the Greenlanders were telling us how the little tiny shrimp are trying to get out of the warming waters. They don't seem to be happy. I don't want to have a theological discussion on happiness, but I'm just.
Yeah, well, I think we're both for happiness, and you know, of course, you
I'm for
know,
happiness without a lot of
animals,
CO2.
animals are animals because they can move around in response to the environment. We do that ourselves, so do fish and shrimp.
That's the point.
Yeah. So what's new? They've always done that.
Yes, I know, but they're doing it now.
Well, you know, songbirds migrate from the cold to the warm south when it's winter, you know, so migration has always...
But they come back. They come
yeah,
back.
Sure, yeah.
And so you're saying that these tiny shrimp will come back?
They will find whatever part of the ocean is to their liking, and that's where they will stay. And if it changes, they'll move again.
Dr. Schneider, please help.
Yes, I'm sorry to... I agree with you about the importance of a civil dialogue, but I'm sorry to say that the ecological naivete in what we just heard is really legion. It's very, very well known that the fragmentation of habitats into smaller and smaller places has nothing to do with climate. Land use and other areas of part of development are a significant threat to the preservation of species on Earth. That's well documented. Now, if you change the climate, as Dr. Happer correctly said, in the past, species have been able to respond, though not all of them fully, but they didn't have to contend with 6.5 billion people, some tightly locked into national boundaries living in nutritional margins, and they didn't have to cross factories, farms, freeways, and urban settlements. So it is the combination, as many reports of the National Academy of Sciences has shown, including some recent ones that Ralph Cicerone could tell you about, that it is what we call the synergism, or the interaction of the fragmentation of habitat and then the forced migration across disturbed landscape threatens what the literature says, somewhere between 10 and 40% of species going extinct, mountaintop species. This is not a happy situation if temperature changes more than a few degrees. And while nobody can tell you whether it's at the 5 or the 50% level, that's the kind of risk which, again, we are dealing with if we're going to have a business as usual. So it's, in a sense, absurd to argue that because things have happened before, it's fine now, because we didn't have anywhere near the scale of the human enterprise. And this is a completely different time than any other in geologic history. And it always has to be analyzed relative to the human condition at the present.
Thank you. I yield back, Mr. Chairman.
Great, gentleman's time has expired. The chair recognizes the gentleman from Washington State, Mr. Inslee.
I appreciate the panel in part because where I live, we are already experiencing fairly dramatic negative changes associated with increasing carbon dioxide. This is not a theoretical issue where I live. We have massive pine beetle kills in the forests of the state of Washington, Alaska by the thousands and thousands of acres caused by changing climate today. This is not a theoretical issue. The park, Glacier National Park, won't have any glaciers in it. It had 135 when I was born. It'll have 0 when I die. I hope if I live the next several decades anyway. We'll have to call it the park formerly known as Glacier. The tundra is melting in Alaska. We are having to move cities. Shishmaref, Alaska is having to be relocated because of the change in the shoreline. This is not some abstract thing. We are already, and it is frankly a little stunning to me for anybody to say CO2 increases are positive when we are already seeing these negative attributes happening to my constituents today. This is not some abstract thing. But I want to ask about a specific one. Dr. Jane Lubchenko, who is an oceanographer from the Oregon State University, who now runs NOAA for us, she has testified that carbon dioxide, when we burn it, goes into the atmosphere, eventually ends up going into solution in the oceans. And she didn't use this term in what I'll call an invisible oil spill. We got a big visible one down in the Gulf, but there's an invisible one every time we burn oil, and that CO2 goes into the water and it creates more acidic conditions in the water. And during previous testimony, we've been told that the concentration of acidic ions is increased about 30% in pre-industrial times at levels that have never experienced this during humans' time on Earth. So first off, just a quick question. Does everybody on the panel agree that carbon dioxide, which has been caused by us burning fossil fuels, has dramatically increased the acidity of our world's oceans? If you can answer yes or no, if we can do this quickly. Thank you.
Yes.
Your numbers are correct, Representative Inslee.
Yes.
Yes, it has increased.
No, it's certainly not dramatically increased. It's changed
Okay, well,
from
I'm sorry.
8.2 to 8.1 or 8.0, something.
Right, well, that's a logarithmic scale as we know in an acidic, but the numbers of ions, it translates to about a 30% increase. Could we have a chart? I want to say, Dr. Happer has suggested this is no big deal and nothing to worry about. Dr. Chaim-Lubchenco, who is our expert in the nation on this, could we put a slide up on this? This is a slide that shows, according to Dr. Lubchenco, what happens to pteropods. Pteropods are these small plankton that constitute about 40% of the bottom of the food chain. And she has shown us experiments about what happens when you put pteropods in water that is as acidic as it will be at the end of this century if concentrations of carbon dioxide continue unabated. And what they do is that they dissolve. You see on the left is a picture of the pteropod shell. It's made out of calcium carbonate that the little structure precipitates out of the water to form its body structure. It's a little shell. Now they put it in water that has the same acidity as the waters will have at the end of this century. And basically over a period of 45 days, you'll show that the shell essentially dissolves. Now, Dr. Lubchenco has told us, who runs the National Oceanographic and Atmospheric Administration, who is a scientist from Oregon State University, she has told us that this presents a clear and present danger to the food chain of the oceans because, of course, this is the bottom of the food chain, these little plankton that end up feeding the whales eventually and the salmon and everything else. Now, she considers that a significant threat. So if I can just ask the panelists, is it a realistic concern that the food chains of the oceans are in danger because of the changes in carbon dioxide which increase the acidity, not to mention the temperature? By the way, we've been told there'll be no coral reefs during my grandson's lifetime because of the combination of acidity and temperature. But forget temperature for a minute, just because of the city. Is it clear that there's a relationship between carbon dioxide and the acidity of the oceans that does present a threat to creatures that use calcium carbonate in the oceans? If we can start, Dr. Cicerone.
Yes, I've gone to several of the conferences where this early work has been discussed, and it's difficult to see any way around it. The changes are large enough, the sensitivity is high enough, and unless there's some unexplored niche which is going to stabilize things, it looks that serious, yes.
Yes, I certainly think it is serious. Of course, if we had several million years to wait, hang around, maybe life would adapt okay, and it wouldn't be a problem.
Yes, I think it's a problem, and again, the issue is the rapidity of these changes. While there have been changes in the past, as Dr. Happer showed, there is no analog in the past for the current rapid changes that we are going through.
It's certainly clear that there will be quite a large number of species percentage-wise that will be threatened. Not all will be, and we have to be careful of anyone who cherry picks only one kind of species, either entirely threatened or not threatened. But as an integral, the ecosystem is an interconnected whole. Knocking out substantial percentages of it is a very high risk.
No, it's nonsense, especially for the plankton, because they have a very high turnover rate, so they evolve extremely quickly because of the very short generation time, so they can easily adapt to anything we can do.
Maybe permitted one more question, Mr. Chair. Thank you, or maybe even two. Dr. Happer's statement is absolutely stunning to me because I think it is totally contrary to any accepted belief by any evolutionary biologist in the world today. And I don't know how to say it in a more cataclysmic statement, but I want to ask this to make sure we give you a chance to answer, Dr. Happer. You have basically said that we shouldn't worry about carbon dioxide because the only thing we really should worry about is if in fact it increases water vapor, if I understand your testimony, that's what really could have cataclysmic warming. But I want to make sure that my understanding is correct that, and I'll just go down through all the scientists here, The increasing acidity of the oceans that we are experiencing through clear, unambiguous results. I met the NOAA ship when it docked in Seattle, when it found some of these results off the coast of Washington and Oregon last year. I want to make sure I understand that there is no question that this acidity will increase with increasing concentrations of carbon dioxide, with or without any changes in the water vapor. Is that the correct scientific conclusion? We'll just go down the panel, Dr. Cicerone.
Yes, of course.
Yes.
Yes.
Well, let me qualify that. Changes in the water vapor means that the sea surface temperature has changed, and that changes the solubility of CO2. So there are slight correlations there, but the first approximation, that's correct. And let me also correct one thing. I didn't say that the key is water vapor. I said water vapor and clouds. I was careful to add clouds.
Yes, I think I understand. Thank you, gentlemen.
Gentleman's time has expired. The chair recognizes the gentleman from Oregon, Mr. Blumenauer.
Thank you, Mr. Chairman. I appreciate your courtesy. I was in 2 other meetings, but I want to just see if I understand correctly. Dr. Happer, just do you think the conclusion of many scientists, some of whom have been represented on this panel, whose research has tended to believe that climate change probably will have catastrophic impacts on the planet. Do you think they're reaching this conclusion based on their interpretation of data to the best of their ability?
Yes, I think they are.
And would you posit that of the many scientists that we have heard from in this committee before and the research that we've analyzed, who believe that there are in fact serious impacts on the ecology and the economy of our planet, and that the impacts might actually be worse than we had anticipated. Now, while you think the changes will be small and may even be positive, would you agree that your position is to be charitable, a minority position of the scientific community?
Oh, yes, I certainly agree. And in many cases in the history of science, the minority has been right.
Mm-hmm. But if you were a policymaker charged with making decisions based on what is a preponderance of evidence from people who in good faith are arriving at a starkly different and more serious conclusion, where there is a catastrophic risk to the economy, the ecology, as opposed to taking remedial steps, many of which are things that experts are telling us we should do anyway, that we shouldn't continue to waste more energy than anybody on the planet, that we ought to be sensitive to the use of fossil fuels. Wouldn't it be prudent for a policymaker to take action based on the overwhelming consensus of the scientific community, to take steps that many think are important to do, even if we weren't concerned about catastrophic climate change?
I think you should take steps that are independent of climate change. For example, energy independence is a good idea.
Yep.
Efficiency is a good idea. All of those are good
Great.
ideas. Preserving the environment is something I'm in favor of. But you should be careful about being stampeded into something. It reminds me, I've often told my friends of the prohibition, frenzy, the temperance movement. So this is very similar to that. They were sincere people. They really thought it would help humanity.
Let me just I will conclude on this point, just because what is intriguing to me, and I agree with you, the stampede for prohibition, but that wasn't driven by an overwhelming consensus of the scientific community with decades now of empirical research. It was largely ideological, political, sociological, without a scientific Foundation, wouldn't you agree that there's a slight difference than what the political knee-jerk reaction to prohibition and listening to thousands and thousands of scientists who are interpreting very clear scientific trends? Isn't there a difference here?
Well, there's a little bit of difference, but actually, there are many scientists like me. I'm not the only scientist, and so there are many who feel the same as I do, and they're pretty good people.
Thank you. Thank you, Dr. Shepard. Mr. Chairman, I appreciate your indulgence, and I agree that you're a good person, and I agree that there are a few others who articulate this. We've heard from some of them because the chairman and the ranking member have worked to make sure that in the course of 3 years we have a broad cross-section of opinion. But because we're legislating for the country, and we are part of a global effort that where we're actually, most people think we're legislating for the planet, it seems to me that there's slightly a different standard and that it isn't a experiment with prohibition. This is based on science. This is based on stakes that are much higher. And with all due respect to a few of the people, some of whom I've had a chance to meet and I find engaging, and I think their evidence is worth listening to, but for policymakers, it seems to me, Mr. Chairman, that it's not even close. And I do appreciate your indulgence here and what you've done to try and make sure that we look at the big picture.
I thank the gentleman very much. And I'm going to recognize myself for a second round and other members as well, if they would like. Dr. Santer, I thank you for your earlier comments on harassment. And I'm wondering if you would be willing to share with us about the form of the harassment which you have experienced, and if you would, how this has affected your ability to do your job as a researcher at one of our national laboratories.
Thank you. This harassment, as I've indicated in my testimony, has really been ongoing since my role as convening lead author of the Detection and Attribution chapter of the IPCC's second assessment report back in 1996. Back then, I spent roughly 1.5 years of my scientific career defending that balance of evidence conclusion of the IPCC and defending myself. Since then, I've encountered sporadic email harassment. People like hiding behind the anonymity of their keyboards and think that if you come up with results that they don't like, they can write to you, they can threaten you. Sometimes this harassment has gone beyond email threats. Several years ago, there was a knock on my door late at night, about 10 p.m. I went downstairs to answer the door. There was no one there, but a dead rat had been left on my doorstep, and a gentleman in a yellow Hummer drove off at high speed shouting curses at me. More recently, things have become a bit more serious in the aftermath of ClimateGate. The nature of these email threats has been of more concern, and because of those concerns, I've worried about the security and safety of my family. It's very troubling to me to think that because of the job that I do and because of the findings I've obtained, my loved ones would be in harm's way. I don't know what to do about that. Another concern is the use, or in my opinion, abuse of the Freedom of Information Act. The Freedom of Information Act is noble in intent to enhance transparency in government. I believe, however, that in the climate science arena and in other scientific arenas, the Freedom of Information Act has been used not as a tool for valid scientific discovery, but as a means of taking up the time of government-funded scientists, engaging in fishing expeditions. Many of the requests that I've seen in our community, some of the requests that I myself have received have been frivolous. I don't know what to do about that, but the concern is that one or two individuals, if not constrained, could essentially use this kind of behavior to overwhelm us. and prevent us from doing science in the public interest. That's a serious concern to me.
Dr. Schneider, what have you experienced?
Well, there's flurries of very nasty emails, for example. A typical one would be you, communistic dupe of the United Nations attempt to create a global government to take away American religious and economic freedom. You're a traitor and should be hung. I mean, I get those fairly frequently. And of course, you just ignore them. You never answer them. The part that's most intimidating isn't so much to me, but my young students and others do know this, so we discuss it. And some of them are concerned. There's been, as Congressman Cleaver mentioned, a loss in civil dialogue, which is very unfortunate, where people come to your meetings and instead of listening, they just shout, how you're un-American. I haven't had too many of those, but I have colleagues who have. And that's unfortunate. So there's been substantial amounts of intimidation of that type. I've had colleagues who've had letters written, myself included. Many of these emails are copied to my deans and the president. Of course, it just leads us to have jokes about it because they understand. But by and large, this has never happened before. We've always had a spirited debate from the first in the 70s when I testified to various bodies of this Congress on these issues. It was always civil. It was always bipartisan. And it's now gotten to the point where things have become accusatory and highly ideological, and that's very unfortunate.
Dr. Cicerone, both Dr. Santer and Dr. Schneider have been listed in the Virginia Attorney General request to the University of Virginia, and you've mentioned about the impact that this level of politicization of science could have upon young scientists. Could you expand a little bit upon that?
I do worry about the young scientists who are referred to earlier as a great asset we have in getting further the kinds of detailed information we need more and more in the future. I remember several years ago when there were instances in our federal government of certain scientists whose testimony to Congress and in their reports was being reviewed at higher levels in the agencies by communications office. And my big concern then, and I communicated with Science Advisor Marburger at the time, was that this would be a big discouragement to some of our best scientists going to work in our own government laboratories. And that's something that we have to encourage the young scientists to work in our government labs. So I worry about this kind of intimidation. In the case of Virginia, having been a university chancellor, I know that universities are pretty good at investigating all kinds of allegations. They can be sexual harassment, they can be racial bias, they can be political investigations. Universities know how to do them, and I think the University of Virginia is very capable of looking into these matters themselves without external threats of legal action, if there is any basis to them.
Yeah, thank you, Dr. Cicerone. Dr. Molina, you won the Nobel Prize for your work in atmospheric chemistry of the ozone hole. Nobody disputes anymore that the ozone hole was caused by human activity and that the banning of ozone-depleting chemicals have helped to solve the problem. How do you compare the certainty of science related to the ozone hole to that of global warming?
Yes, the science of ozone hole started perhaps as a minority opinion, but then, of course, the scientific community examined it very carefully, and experiments were carried out, and so the science became very sound. In the case of stratospheric ozone, we have very clear experiments that show that that is the case. In the case of climate change, I must say that there have been very impressive advances in recent years, but as several of us expressed here, we certainly acknowledge that there are uncertainties, and that's why the risk needs to be evaluated. So the climate system is very complex, but I believe the scientific community, with honesty and so on, has really concluded that the problem is indeed very serious, and it's assessing it in terms of probabilities. So the science is perhaps, it's certainly not perfect, perhaps it's not quite as clear as in the case of the ozone hole, where you had this enormous phenomenon that you could directly examine with measurements. But nevertheless, we have very striking evidence of increased frequency of floods, of droughts, and so on. So to me, that's, as we heard before, of course, that's what you need as a policymaker to make decisions.
Dr. Molina, can you explain why you think there is so much manufactured controversy around the issue of global warming? What is special about this issue that draws so much manufactured controversy?
I think there are a number of factors. There are certainly interest groups that feel that they will lose, talking about perhaps business interest and so on. But there's also within the scientific community, perhaps there are some well-intended scientists that question the veracity, the authenticity of the science. But I think it is the fact that this question has been examined in such a way that the news media has sort of very much exaggerated the questions that are around the science itself. And just the fact that this is a new situation for human society, that it is very clear that human society can actually affect the function of the planet. It was already clear with the ozone layer, but it was not as pervasive. All of our activities connected with energy are affecting this situation. So I think it's just the size of the problem and the economic implications, which are also often not well understood, that explains the big difference.
Thank you, Dr. Molina. Chair recognizes the gentleman from Missouri, Mr. Cleaver.
Thank you, Mr. Chairman. Mr. Harper, let's go back to the garage. We both agree that carbon monoxide doesn't create joy. And so it will kill in a closed situation. You got to help me. We got the troposphere right here, down here, and then there's the ozone layer, and then the stratosphere. I guess the ozone layer. Am I scientifically sound?
Yeah.
Okay. So, do you agree that there are holes in the ozone layer?
Yes, over South America and over the South Pole in the spring, southern spring.
And so stay with me and help me. So then we're not getting the protection that we would normally get in our atmosphere, because some of the Earth sun's rays are coming in. They're not able to bounce back out into the stratosphere. Am I right?
Well, I guess if we're talking about ozone, the concern there is the ultraviolet B,
Yes.
Which is absorbed by ozone.
Okay, stay with me.
And there are a couple things to remember, that it is over the South Pole. Not many people live there. And also, in the spring, the sun is just barely over the horizon, so it's going through a very large slant path. So, in fact, the effects on living things are not very big. Yeah.
So, but you're saying that because it's over the pole, South Pole, that that essentially it cancels out any negative impact.
Well, Yeah, the point is that the sun is not shining from overhead in the south polar spring. You know, it's just barely beginning to come above the horizon. You know, it's been below the horizon. And so it's during that period that the ozone hole develops.
Okay.
And
So in the garage,
yeah,
if we had a way for the carbon monoxide, the tailpipe emissions, to get out, bounce out of the house,
right.
The person in the car might survive.
Yes, absolutely. Good ventilation, like this room has good ventilation. Without it, the CO2 levels would be several thousand. You're right.
Okay, thank you.
The gentleman from Missouri's time has expired? Okay.
My time has expired, hopefully. We'll get rid of some of the CO2 and my time won't expire. But the point I'm trying to make, because I may be misunderstanding you, tailpipe emissions are not bad. They're not creating a negative problem.
Yes, they create a negative problem because of the carbon monoxide, the CO, not the CO2. They have CO2 also, and water and all sorts of other junk.
Yeah.
But the CO is the bad stuff.
Uh-huh.
Yeah.
And so the carbon monoxide is getting out of the atmosphere.
Well, it gets into lots of things, put CO into the atmosphere, cars, as you mentioned, and it slowly gets oxidized because of the OH radicals and ozone too, for that matter.
And
so it doesn't last long.
And so it cancels it out.
It's eaten up by oxidants in the atmosphere.
So fossil fuel, the burning of fossil fuel is neutral. It creates no problem because we've got something is eating it up.
Well, what gets eaten up is the carbon monoxide, and which is very dangerous, very poisonous. And the CO2 doesn't do anything because as you and I breathe, we're exhaling CO2, which is much more concentrated than you get in the exhaust of the car, or at least comparable to that. You know, 40,000 parts per million. It's a lot of CO2. Mm-hmm. That's why the CO2 in this meter is so high.
I know, but the point I'm trying to make is that tailpipe emissions are not doing any damage to the atmosphere.
Well, if you're in the Los Angeles basin, for example, they create smog, usually not because of the CO, but because you don't burn all the hydrocarbons, you know, and then with complicated, you know, chains of reaction, it makes this horrible haze that covers Los Angeles.
So if it's in Los Angeles, people in Waxahachie, Texas shouldn't be concerned.
Well, I think they should be concerned. You know, I have a daughter in Los Angeles, you know, and many people have relatives. It's, you know, you want them to have a healthy environment. So I'm all for getting rid of smog, and, you know, you can do that by, you know, technical means.
Dr. Molina,
my opinion on this, of course, I think we're talking about air pollution, which is clearly something that should be controlled. Fortunately, new devices, catalytic converters and so on, remove a significant fraction of this carbon monoxide that is emitted. But air pollution is just a good analogy. It's something we have technologies to eliminate, and society wouldn't question now the need to use catalytic converters. We could not live in Los Angeles. The air in Los Angeles in the 1960s was just unbearable. So society had to invest to remove these pollutants. And even though that was questioned at that time by some sectors of society, some economic interests, that's the analogy, nobody questions that now as certainly a wise solution. There is another important connection, because air pollutants turn out to not only have a large impact from the public health perspective, but they also affect climate. Besides CO2, tropospheric ozone and soot and so on are significant factors in the climate change issue. So we certainly need to take a very close look at all these activities of human society many of them connected with burning fossil fuels, and they all point a clear need to change the way society functions so that we preserve not just better human health in urban centers, but a better functioning planet. That's very clear.
Thank you.
Gentleman's time has expired. The chair recognizes the gentleman from Washington State, Mr. Inslee.
Thank you. I've just taken a look at this demand letter from Attorney General Cuccinelli of Virginia, demanding correspondence of dozens of scientists, including Dr. Santer and Dr. Schneider. And it is the most clearly abusive thing that I've seen for a long time, basically trying to treat scientists, Nobel Prize winners, like members of the Corleone family. And I'm just offended at the use of, and I used to prosecute cases. I have to tell you, I'm offended of somebody politicizing a science like this in an obvious attempt to intimidate people who are trying to get at the truth. And I just have to say that. I want to read a letter that was published in Science magazine May 7th. And it's an open letter. It was signed by about 250 United States scientists. They are all members of the United States National Academy of Scientists. These are respected people. Here's what they said, and I want to see if members of the panel agree with what they said. This is just a paragraph out of their letter. We also call for an end to McCarthy-like threats of criminal prosecution against our colleagues based on innuendo and guilt by association, the harassment of scientists by politicians seeking distractions to avoid taking action, and the outright lies being spread about them. Society has two choices. We can ignore the science and hide our heads in the sand and hope we are lucky, or we can act in the public interest to reduce the threat of global climate change quickly and substantively. The good news is that smart and effective actions are possible, but delay must not be an option. Can I just ask the panelists if you agree with that statement? Dr. Dushway?
I don't think I would have used the word McCarthy-like tactics. I think it just escalates. Otherwise, I agree with it.
I agree.
I agree.
I signed it, I agree.
Well, I agree with the first part. I'm against harassment, and there's been too much of it for too long of science, but it didn't start with Virginia, a lot of it started here on Capitol Hill. Many of us remember John Dingell's prosecution of David Baltimore, for example, which was every bit as bad as this. So I'm certainly very much opposed to that, and I hope it can be stopped. I think the statement is conflated with, taking immediate action on, CO2. I don't agree with that part.
So if Mr. Cuccinelli was here today, Dr. Happer, would you tell him to knock it off? You think that's an unwise
Yes, definitely.
Well, I appreciate that statement. I wanted to talk again a little bit about ocean acidification. Dr. Hapter has suggested that these are small changes in the acidity of the oceans, the relative acidity, because on a logarithmic scale, the changes are from about 8.2 to 8.1, and maybe it'll go down 8.0 at the end of the century. He suggested those are small changes. Dr. Molina, could you give us a little chemistry lesson about why you may not think those are small changes?
I think it's misleading to say it's small or big. We're talking about small changes in the concentration of CO2 in the atmosphere, or very large changes depending on the context you're talking about. So from the perspective, as explained by Dr. Jane Lubchenco, those are very worrisome changes. That's what I would state clearly. But you measure the effects on ecological systems, and the effects are clearly noticeable, and they would have a significant impact on the food chain. I would call those very worrisome changes. Whether small or large, that's just a semantics, perhaps.
Thank you. And you've indicated worrisome enough to suggest we actually take action. Is that right?
Yes,
Thank you. Dr. Happer has suggested that we need not worry about this problem because evolution will take care of it. As the oceans become more acidic as the Arctic melts, as the tundra melts, as Greenland melts, as the pine beetles ravage the forests, as they have the forests of my state by the thousands of acres, that evolution will just solve these problems. Is there anything in the literature to suggest that the polar bear can evolve fast enough to maintain its continuity with no Arctic ice to live on and hunt from? Is there any suggestion the polar bear can sort of just evolve in the next maybe 2 or 3 generations to be a land-based species and find how to, build hunting traps of its own or something? Is there any suggestion in the literature that that can happen in the next 2 or 3 or maybe even 10 generations of polar bears? Yeah, go ahead, Dr. Apper.
Well, it's pretty clear that during the Neolithic, 4,000 or 5,000 years ago, northern hemisphere was probably 3 degrees warmer, 2 or 3 degrees warmer than now. The polar bears did just fine.
And how about coral reefs? Is there any suggestion in the literature that coral reefs, Dr. Ken Caldeira of Stanford is a world-renowned oceanographer, was here some time ago and said that at the acidity levels that we will experience by the end of this century, because the acidity levels are changing and increasing in the oceans, at those acidity levels, it is doubtful that there will be any healthy coral reefs on the planet Earth. Looking at the way coral responds to changes in acidity, is there any suggestion that coral reefs within that period of time or some kind of evolve a new way to precipitate calcium carbonate out of the ocean so that they can remain healthy? Is there any suggestion of that?
Well, again, most of the coral reefs and, that we see, the fossil coral reefs, were at, much more acidic conditions, by the standards we're talking about now, because they evolved with CO2 levels that were thousands of parts per million.
Well, this is one place, Dr. Happer, that I'm going to have to respectfully disagree. I understand you're a man of science, but you're not an oceanographer or a biologist. And the biologists and the oceanographers tell us that, in fact, those life forms have not existed in anything close to levels of acidity that exist in the world's oceans. Does anyone disagree with that statement? Other than Dr. Appner. Dr. Schneider, yes.
The biota that existed way back, in the era of the dinosaurs and so forth, when we had more CO2 and warmer, were very, very different than now. They didn't also have to deal with all the other multiple stresses associated with humans, like toxic runoff and warming oceans at high rates. It's the rates that really matter. And therefore, you cannot use that analogy, because even though nobody would argue that all life will disappear, in fact, warming will make some species better off, the problem is, how do you maintain the vast diversity of life to which we have had a coevolution of climate and life when you have very, very rapid disturbance? That's the worry. The worry is losing tens of percents of the existing species, not that there won't be some species that will do better. And losing tens of percent is a very significant threat to the ecosystem, particularly when it provides services such as food that we need. If we lose the coral reefs as we now know them, even though there'll be some that will survive, then a major source of protein for poor people is lost, in addition to these little entries, as I think of them, as nature's books in the Library of Alexandria, these existing species which have co-evolved over this time. And there's a fundamental ethical question whether we should risk losing them just so that one species gets so much richer a few years faster.
So if I can ask just, I was in Panama and met a scientist who was studying the effect of carbon dioxide on the rainforest. And he was up one of these cranes that, go around 2 acres. It was actually the first one ever in use. And he said that they have found that the lianas, which are the vines, have increased their acreage that they cover at the top of the forest by as much as 30%, because the lianas can metabolize carbon dioxide much faster than the other structures in the forest that take a structure. They don't really have any structure, they just grow leaves, so they go nuts. So he basically said the lianas are taking over the forest canopy of the rainforest. So it is good for lianas, but bad for the structural stuff that it can eventually choke out. Now, what he told me, and this has stuck with me, he said, you know, we are involved in the largest experiment in the history of the planet Earth, and we are the guinea pigs. And we don't know how this is going to turn out. Just going to ask your comments if the panelists agree with that assessment.
That's a pretty fair assessment. Roger Revelle and other people said it 30 years ago, referring to this great geophysical experiment. For example, on the ability of some species, plant species, to prosper. Carbon dioxide is not the only limiting nutrient. They also have to have water, they have to have nitrogen fertilizer, trace minerals, and indeed the paths of photosynthesis in some cases don't even depend directly on the amount of carbon dioxide, the different paths to photosynthesis. So sorting all of this out is going to take a great deal of commitment, and the problem is the changes are happening faster so far than our ability to sort it all out. That's why people talk in this grandiose terms about conducting an experiment that we don't know how it's going to turn out.
I certainly agree as well. We are conducting that experiment, and we already see some evidence that what the thinking is, if the Earth warms only a little bit, clearly there might be beneficial effects and also effects that are not beneficial. But what seems to be a consensus, we see that from the frequency of droughts, floods, and so on, there seems to be a consensus that if we change the system significantly, because we're doing that very fast and because society is very vulnerable, that's another big change we have now with respect to 50 million years ago. We have 6 billion people on the planet, and so the society is very vulnerable now. So with these very fast changes, we would certainly be limiting the feasibility for them to really have economic well-being as they deserve.
Yes, I believe we are performing a grand experiment, and there's no control. There's no parallel Earth without human intervention. That's of concern to me. As Dr. Happer correctly pointed out, things have been different in the geological history. There have been changes in carbon dioxide, other greenhouse gases, clearly changes in the fauna and biota. But the key thing here is that we are now a forcing of climate, and the changes that are happening now have no geological analog. They're too rapid. We don't know how this experiment is going to turn out, but it is happening. Like you, I actually see evidence of this. I'm a climber. I've spent a lot of my life, the last 35 years, in high alpine environments around the world. I've seen these changes in glaciers. I've seen these changes in fragile, high alpine environments. They're real, they're happening now, and future generations will be experiencing these places in a quite different way from the way that you and I experience them. That's a cause for serious concern for me, at least.
Congressman Inslee, let me rephrase your correct insight that these things operate as a system. Remember, it's called an ecosystem because it's a system. If you take any individual plant and you put it in a chamber and you give it more CO2, it generally likes that. When you go out in a system, as Ralph Cicerone said, with multiple nutrient variations, some plants are given competitive advantage over others. You can actually decrease some plants by crowding them out. So you're making a very rapid change to a system. And what that does to the structure, and most importantly for us, the functioning of that system, there's a great deal of uncertainty. But this experiment that we're performing, and I would obviously have to agree with your question because my 1997 book had the title, The Laboratory Earth, the Planetary Experiment We Can't Afford to Lose. So clearly I agree with the metaphor. However, we're not entirely ignorant. And remember, as I said earlier in my testimony and as the IPCC frames and National Academy studies, We can sort out components of this that are well established, we really are not ignorant at all. And if we didn't have many of them, you would not find a large numbers of climate scientists expressing concern as we are now. Then there are components with competing explanations where we worry about the coin flip odds, but there are still going to be speculative parts. So we do not know the full outcome of this experiment, but we're absolutely certain that we're going to confer advantage to some species at the expense of others, which will cause extinction, and we're absolutely certain that most people don't think that that's a good idea.
Well, the climate has changed all the time over all of geological history on every time scale from, decade to decade to century, millennium to millennium. So just during the past 10,000 years, there have been many periods when it's been much warmer than now. In fact, there were periods when there were no glaciers in the West. So things like Glacier National Park are not an old feature, they're a fairly new feature, even during the last 10,000 years.
Thank
you, Mr. Chair.
Gentleman's time has expired. I'm going to ask Dr. Cicerone a question, and then after I finish with that, we're going to come back in reverse order and ask each of you to give us a 1-minute summation of what it is, a 1 minute, minute and a half summation of what it is that you want this committee and the Congress to know as we move forward, taking into account the fact that Senator Markey may actually bring a resolution to the Senate floor within the next several days to overturn the endangerment finding made by the EPA on the question of the impact of CO2 and greenhouse gases on our planet. So this interaction of science and politics is very clear, and it's something that could be debated on the Senate floor almost immediately after the conclusion of their debate on the financial regulation overhaul bill, which they are now considering. Dr. Cicerone, you mentioned that the National Academy of Sciences issued 3 reports yesterday. Can you briefly outline the recommendations of the reports on policies needed to reduce carbon dioxide and to adapt to climate change impacts?
The report that was released yesterday was requested by the previous Congress more than 2 years ago. And as I said, we divided up. The request was basically, if I can paraphrase, to issue a report stating what we know about climate change, how real is it, what are the causes, what to expect, and then what should the country do about it, if I'm paraphrasing. The panel on the science of climate change has received most of our attention this morning. What we've already known, how we know it, how we can improve our knowledge. The experts who wrote that report and our reviewers agreed that it is important to continue the physical science side of climate research, of course. We need a lot better information. They think it's also important to tune some of our future research towards the needs of, for example, how we limit the amount of climate change to happen in the future and how we adapt to the changes which cannot be managed. So the second and third part, and they said that the evidence for climate change is very credible and strong, and it has grown over the last 4 or 5 years as well. The limiting part of the report focused on the need for, instead of doing something for 1 year, to come up with a longer range strategy that could be sustained and improved with time. So they focused on, for example, carbon dioxide emissions over a period of the next 40 years and said that there's a need for a national target of what should be the cumulative emissions over the 40-year period, and then come up with strategies to deal with it, starting with the easiest things like energy efficiency and the low-hanging fruit, all the way through to further out basic research to identify completely new technologies, because they concluded with any reasonable target for total emissions between now and the next 40 years, we don't have the technologies in place on the shelf to meet the energy needs of the growing world population. The third part of the report was adaptation, and the goal there was, given that there will be some changes which cannot be limited, cannot be avoided, how should we adapt? And rather than trying to come up with a detailed strategy for every locality in the country, because the local needs and the regional changes are different, they emphasized the need for a national strategy which would play out locally. How to encourage and coordinate adaptation mechanisms which must be placed locally, the needs of the Gulf Coast being different from the Pacific Northwest and New York City, for example. So that was, in essence, they're taking the problem, the report takes the problem seriously. It says, as Dr. Molina said a minute ago, that the future size of the problem looks unmanageable unless we commit now to a sustained strategy of limitation and adaptation.
Thank you, Dr. Cicerone, very much. Now we'll ask each of the witnesses to give us their summation statement to the committee, and would ask you to limit it to a minute or so. And we'll begin with you, Dr. Happer.
Well, my advice to policymakers here in Congress is that you take a deep breath and think a little bit more about the scientific evidence, and remember the oath that you doctors used to have to take. You know, it's first do no harm. And in the case, I mentioned the similarity of this excitement to prohibition. And then too, as I said, you know, everybody was for it, and they were for it for sincere reasons. You know, I can understand that. But it was the wrong thing to do. So it was the only amendment that has ever been repealed. So I hope you will remember that and be careful what you do.
Thank you. Dr. Schneider.
Yes, just a few hanging points I'll try to do quickly. One is we've been talking about this issue of skepticism, and some have done denial. I just want to very quickly put in perspective, there's no such thing as a good scientist who's not a skeptic. I began my career thinking that dust and cooling was more likely than warming, found out what was wrong with it, and I'm very proud to have published first what was wrong with my own ideas. We evolve our ideas on the basis of evidence. A denier is someone who does not admit the preponderance of evidence based upon the overwhelming amount that's out there. That is exactly what IPCC and National Academy of Science does, is it convenes teams to assess preponderance, because individuals are not very good at assessing risk by itself. That's the what can happen, what are the odd parts. Our job in society is risk management, how to deal with it. Number two is I am disappointed that Congresswoman Blackburn left, because she made a statement that I hear all the time when I get these angry emails. Well, you're just in it for the money. So what really is frustrating to those of us who do this is that if our strategy were to get money, then the last thing we're going to say is that it's unequivocal that there's warming and very likely that humans are responsible for most of the last 50 years, because then you don't need us. Then you're now making risk management judgments. What we'd say is we don't know anything, fund us to do it. So not only are we being accused of dishonesty, but we're also being accused of being pretty dumb. So what we do is separate out the relative components we know well from the others. And it is not at all about getting grants. That's just simply a political statement I would love to discuss with the Congresswoman. Also, Congressman Sensenbrenner made the comment that climate scientists were very frustrated and had inappropriate attempts to control things. Well, yeah, they were very frustrated. There were a tiny minority of scientists, and their frustrations were never acted on by the IPCC. But for those people who claim it's only climate scientists who express human emotions of frustration, why don't they just simply release the so-called climate skeptics, all their interchanges of their own emails over the last 10 years, and let the public decide which of them have been more strategic in their plans. And until they do that, their accusations have no merit whatever. And finally, I wanted to come out and say, from the committee's perspective, In the conversation that Congressman Cleaver was talking about air pollution, and everybody agreed that getting the pollutants which are health-threatening out of cities is a good idea. Well, some of those pollutants are generated by inefficient processes. So let's look for co-benefits and win-wins. And obviously in the legislation that you've been involved in, you're trying to find those elements where solving one problem also help to reduce CO2 emissions so that you can solve both at once at relatively lower costs. It's a very, very good operating principle. And the final thing is the question of civil dialogue. For a very, very long time, there was an unwritten social contract between science and society, especially the Congress, where, again, our job was risk. What could happen? What are the odds? And your job is what to do about it. And this water gets muddied by the people who don't see preponderance, by the statements of attributing to people that they're doing it for money or other kinds of things. So then what happens is it becomes a political story, and the risk part and the risk management part get lost in the middle. The public is confused, and unfortunately that's the state that we're in now, and I appreciate the opportunity to try to see if we can get that restoration of civility and the separation of function between the science job of risk and the public policy job of risk management. Thank you, sir.
Thank you, Dr. Schneider. Dr. Santer.
I'd like to follow up on that briefly. Like Steve, I believe that we're impelled by curiosity. Scientists want to figure out the way the world works. They want to get the science right. That's why I chose to be a scientist, not because I had any hidden agenda there. And the work that I do, fingerprinting, has been fascinating to me. It's like a big detective story. Who done it? Was it the sun? Was it volcanoes? Natural climate variability? The powerful thing in that work is that you're looking not at just one global mean number, the average temperature of the planet. You're looking at very detailed geographical patterns of change, altitudinal patterns of change. You're looking at different variables. As I've said, not just the surface temperature, but variables related to the ocean, to atmospheric moisture, to atmospheric circulation, to rainfall. And the bottom line from all of that work is the climate system is telling us an internally and physically consistent story. And the message in that story is natural causes alone cannot, repeat, cannot explain the observed changes we've seen. You have a very difficult job. You have to figure out what to do about it. I believe that it's important for you to do that job based on the best available scientific information. Again, some of the developments we've seen over the last 6 months in particular are worrisome to me. I think there are powerful forces of unreason, as I've called them out there, forces that would like to mandate the scientific equivalent of no-go areas. You do research in that area and come up with findings we don't like, we will come down on you like a ton of bricks. I do not think that that is in the best interests of the American public. I think that in order to take smart decisions on what to do about climate change, we need an informed, scientifically savvy electorate, and I hope that you will allow us to let that happen.
Thank you, Dr. Santer. Dr. Molina.
Yes, I want to just summarize some of what I said in my testimony before, namely that the science is very clear, namely that the science of climate change, that there is a significant probability that if human activities continue unchanged, that we will seriously impact the climate with potentially very, very negative consequences. And that's the type of information that allows decision makers to evaluate the risk. I must add that there's another important component. What does it take to address this change? And that's for economic studies and so on. And there, again, it's clear that we're not talking about huge sacrifices. We're not talking about, even for developing countries, threatening their economies so that everybody achieves a higher standard of living. If we do it cleverly, it's quite clear from this perspective that the risk of having serious damage to society is serious, and the probability is much larger that we will suffer if the necessary actions to confront climate change are not taken by decision makers like yourself. So I think the case is quite clear from this perspective. And lastly, I just want to mention in the context of our testimonies here, that I certainly agree that we have to respect minority perspectives, and minority opinions in science have had important roles. But in this case, what I do is challenge these minority opinions, that I haven't seen reports or documents or articles in the literature recently that seriously question these challenges. Of course, I'm not talking about the existence of uncertainties, but I think the incentive there is precisely the other way around, when it's often said that you cannot get these articles published because of the peer-reviewed system. No, if you actually can document and make a strong case, clear, scientific, and so on, that would be very valued by society. You would become famous. It's far from happening. There are practically no, I'm sorry to say, but I haven't seen in recent years anything serious in the literature questioning these basic conclusions that we are reaching.
Thank you, Dr. Molina. And Dr. Cicerone.
Yes, thank you. First, I'd like to say that the United States science effort on climate change is really admired around the world. We've been leaders, and we really would like to stay that way, partly because to be able to recognize claims that are made elsewhere in the world and to evaluate what the rest of the world is increasingly coming up with, we have to be in a leadership position. And that's going to take a sustained commitment. In my contacts with the business community, which are frequent, I think a lot of business leaders are willing to work with you and eager to work with you to create a sustained commitment, not only to the scientific research, but also to an effort to limit the size of these climate changes and to get on with preparing adaptation mechanisms for the ones that do occur, to take preemptive action and effective action. And I think that the world markets that will develop for more energy efficient products, for example, and ways to deal with these issues are substantially positive, and the United States can and should be in a leadership position, but it's going to require a sustained commitment.
Thank you, Dr. Cicerone, very much. We thank each of you for your testimony here today. It's especially relevant in a period of time that could be immediately preceding Senator Murkowski's resolution coming out onto the Senate floor, which would reject the EPA's finding that CO2 is a danger to the planet. That kind of debate, in my opinion, is the same kind of debate that occurred during the Scopes trial in the 1920s over the issue of evolution. It's the same kind of denial that was based upon religion, and here it would be the religion of fossil fuels as opposed to the actual science of the time. I think in the 1920s, religion, unfortunately, was still given too much credence when it came to the questions of science. It was given too much credence in terms of prohibition. And in both instances, history looks back and wonders why so much weight was given to religion in its impact on public policy, both on prohibition and on the question of evolution. Well, we're about to have that debate again in the United States Congress, as unbelievable as it may seem, given the scientific consensus that human activities are leading to a dangerous warming of our planet. Your ability to be able to bring science to Congress ultimately is going to be central to our ability to put the policies in place that will make it possible for us to avoid the most dangerous consequences of global warming. The planet is running a fever. There are no emergency rooms for planets. So as a result, we have to engage in preventative care. And that will mean relying upon the science that will give us the impetus to put the policies in place that will reduce the chance that we will run those, that we will in fact inflict those dangerous global warming consequences on the planet. We thank each of you for being here. This hearing is adjourned. Thank you.